This is section 8.4, and today we're going to talk about properties of rhombuses, rectangles, and squares. For a quick recap, we're going to talk about parallelograms, which is our first one. Remember, parallelograms are defined by having opposite sides parallel. I'm going to go ahead and mark that. All right, and then once you have a parallelogram, or if you've established that it is a parallelogram, then you have some other properties of parallelograms that you can use to solve problems. So first off, opposite sides are congruent. And these we talked about in the previous lesson, so I'm just going to mark those. We've got diagonals bisect each other. So it would look like this. We've got opposite angles are also congruent. So that's this whole angle and that whole angle. And then this one, we'll put 2 marks on that, and then that one. Kind of wrote right on top of that line. And consecutive angles are supplementary. Means they add up to 180. Those are all the properties of a parallelogram. Now, as we move into the next two, these are parallelograms. So all of these properties come into both of these boxes because this is a parallelogram. It gets all of this plus a couple of its own. So this side is a rhombus. And what makes a rhombus is having 4 equal sides. So I'm going to mark that. But it also gets everything that a parallelogram had. So opposite sides are parallel. It gets diagonals bisect each other. It gets opposite angles are congruent. That right there. And then this one, we'll kind of sneak it in there. And then consecutive angles are also supplementary. The sides are, oh my gosh, are congruent. Sorry. I filled it up there. And diagonals do 2 different things. Oh, nope, sorry, they don't. We are bisecting opposite angles. And what that means, you're cutting an angle in half. So it's going to be a little tricky for us to mark. So this half and this half are equal, and they're equal to these 2 halves. And then this one and this one are equal, and they're equal to these 2 halves. So kind of, it's getting a little messy in there, but they bisect those opposite angles. We need to add one more line down here. I thought I had done it before I made copies, but they also, diagonals meet at 90 degrees, which is kind of nice. So I get this 90-degree angle there, and then I get it on all 4 corners. What that's going to do is it's going to bring back Pythagorean's theorem, and it's going to bring back SOHCAHTOA. So as soon as I have that right angle in a triangle, I actually have 4 little triangles in there, I can do SOHCAHTOA or Pythagorean's theorem in those problems. Next up, we've got a rectangle. And the definition of a rectangle, or what makes a rectangle, is that it has 4 right angles. Angles are congruent, sure. In this one, the diagonals are congruent as well. So let's get all our marks on there. We are a parallelogram, so that means opposite sides are parallel. Oops, just 1 mark. Opposite sides are congruent. Opposite angles are equal. Diagonals bisect each other, and the diagonals are congruent, which means this is equal to this, but they're also equal to those. So all of those in there are equal. And I think that's about it. We've got the angles are equal, consecutive or complementary. Yeah, I think we're good. Last one is a square. And as you move down kind of this tree or this web of pictures, everything that was in parallelogram went here and here, and then these 2 had their couple of extras. Everything from above is going to flow down to square, and then square has a couple of extras. So what makes a square is all angles are 90 and all sides equal. So this is its rhombus property, and this is its rectangle property coming together to make a square. So all angles are congruent. Diagonals bisect opposite angles. And all the bisected angles then are 45-degree angles. I'll show you what I mean. Opposite sides are parallel. Let's start with that. All four sides are equal. That's its rhombus property. Rhombuses have 90-degree angles at their diagonals, so we'll throw those in. Opposite angles are equal, but in this case, all the angles are the same. I should have just made that be a box. There we go. This diagonal bisects this diagonal, so that's equal to this. These diagonals bisect these angles. So this 90-degree angle just got cut in half. Each of these are 45s. All of these are 45s. And then that might be about it. But since you got a 90 in the middle, this will also bring back Pythagoras' theorem and SOHCAHTOA. So let's try a couple with it. It says the diagonals of a rhombus, so it's telling you what shape it is. They intersect at T. So since I'm a rhombus, I know these are equal. I know there's 90s right here. I know angles got bisected, so if this is 30, this is 30. And then across is the same thing, so 30 and 30. So first we're talking about QPR. I'm just going to trace that. So from Q to P to R, you're just looking in this corner right here, so that's 30 degrees. Next I've got QTP, so from Q to T to P, right there, and we filled that in with a 90. Next I've got RP, which is from here all the way across. Well, this much is 6, and since they're equal, this has got to be 6, so the whole thing is 12. And then QT is my last one, this right here. I unfortunately don't have any measures that'll help me out right there. So I'm just going to use this triangle, try and only look at this one, shade it in a little bit. And we're going to do some SOHCAHTOA on that triangle. So I'm going to draw straight through my 90, get my hypotenuse. For my 30-degree angle, this is my opposite. This would be my adjacent. And we know that that's 6 because it's got to be the same. So I'm going to use opposite and adjacent. So it looks like I've got tangent of 30 equals opposite over adjacent. Grab my calculator real quick. And we're just going to do 6 times tangent of 30. Whoops. 6 tan 30. And I get about 3.46. Two more. This one we're going to have to actually draw our own picture. So it says for any rhombus QRST. So here we go. Here's my rhombus. All sides are equal. You can pick any corner to start on. It doesn't matter. And then once you start putting out your letters, you have to continue in a circle around the shape. You can't go QR and then ST. It's got to continue around in a circle. We're deciding if this statement is always, sometimes, or never true for a rhombus. Q and S. These two angles, could they be equal? That is an always. Opposite angles in a parallelogram are always congruent, so that's an always. Next up, I've got Q and R. Now, these are next to each other. Consecutive angles are supposed to add up to 180, and there's only one time that they could equal each other and add up to 180, and it would be when these are both right angles. And that only happens if you have a square. So this is a sometimes. If this shape turns out to be a square, then we would be okay. Squares are rhombuses, but rhombuses are not squares. So if these turned in, if it kind of stood up straight and became a square, then that would be a sometimes. It could happen. Next up is for any rectangle. A, B, C, D. Again, doesn't matter what corner you start on. Just make sure you follow it around in a circle. A, B, and CD. So A, B is right here. CD is right here. That's an always. Opposite sides are always congruent in a rectangle. And then we're talking about AB and BC. Those two sides, they could be congruent, and it only happens again when you have a square. So a square would have these two sides being equal. So if this rectangle shrunk in a little bit and still maintained that it was a rectangle with its 4 right angles, as soon as those sides became equal, then it would be a square, so that is a sometimes.